Good day, students. Now we are going to see an important chapter in a NEET physics session, that is work, power, energy. Just now we discussed what is work. Work done. Work done is equal to force into distance. Force into distance. That you need not see that book. You have to tell everything momentum. So work done is equal to force into distance. Velocity or speed is equal to not distance by time, rate of dx by dt, that is rate of change of distance with respect to time. Okay, for example, something and acceleration is equal to dv by dt, that is rate of change of velocity and with respect to time. So that means I am going to Kodambakam railway station. I am taking the next nearest Vambalam railway station. The total what is the total distance will be approximately 1 kilometer. So then so it 1 kilometer. What is the I am taking train, not by walk. So what is the time you are taking? 1 minute. So 1 kilometer I have covered in a 1 minute. So this is what so this is what that so the velocity, what is the velocity of the speed? Then it is 1 kilometer in 1 kilometer in 1 minute. So 1 kilometer by 1 kilometer in 1 minute. So for 1 minute I have travelled 1 kilometer. So similarly, so I have spent some so what is the energy that I have spent? Some energy I didn't spend any energy because train only spend the energy. Okay, energy spent by means 0. But what is the energy that is spent by the train? You understood the things. Kinetic energy. No, kinetic energy, okay, that's science part. Just I am saying you need to provide the fuel to the train. So what is the energy, fuel that we are providing to the train? Yeah, anything. No, energy only we are providing to the train to travel from Kodambakam railway station to the Mamra railway station. What is the energy that we are providing? Yeah, electric train. It's electric train, so we are providing the electricity. That's all. So that comes here now, electricity. So the work, we have started with the work. Any work you have to do, you have to provide it with the energy. You need not be electric train. You can take the diesel engine also. Diesel train also you can take. Of course, there is no diesel train is not available. I am telling it. It's only so it's about the electricity or diesel that we are providing. That is not anything. What energy we are providing it. So the energy that we are providing some energy. So what is here? Work. So work we need to do the work. We have to provide the energy. So that's why they given the more thing: work, power, energy. So all three are related together. All three things are related together. So you understood now this concept. Yes. Work for doing the work, you need to provide the energy. So what is the second work we can take? You can tell your second work and you can tell the what energy you are provided. Any work you can take.
To move the bench.
No, that's different. Just some other work. Any work you can take. You have to give the what energy you are providing. I understood. I finished the work. That the energy that provided is electric. Taken train. I travelled from Kodambakam railway station to the Mambalam railway station. I reached the thing. The speed I reached is velocity is 1 kilometer in 1 minute. So 1 minute I took to travel it to 1 kilometer. The energy provided is I have not provided any energy. I don't have any energy. Okay, I have provided the train is electrical energy. So electricity I provided, which is a type of energy. So you have to tell me now what work you are going to do, what energy you will provide. Any work.
Cooking heat energy.
Something.
To open your door.
Kinetic energy.
Who is coming from your house?
Walking.
Bus.
Who is coming from your house? You. From where you are coming? From that's a thing. That's all. Why you are blinking? So KK Nagar, you are coming to here. So how you came here?
Walking or
By? By?
Bikes.
By bike. Okay, bike. That's all. So you have provided. You have provided. You took a petrol or a diesel? Petrol. So you are given something petrol. Let's say how many KK Nagar to here means it will be obviously it will be more than 5 kilometer. No, it will be nearly 5 kilometer. So for 5 kilometer means you have to take at least 2 liter, 1 liter of petrol. Not 1 liter. 1 liter gives 20 kilometer. No, 1 liter gives 20 liter. How many liters it will give? 1 liter. 1 liter of petrol. How many kilometers it will give? 20 liters. 20 kilometers. So 5 kilometers 2. So up and down you have to spend half a liter of petrol. So you are given you have spent half liter of petrol to move from up and down. From here to 5 kilometer, from again reaching 5 kilometer. So 5 to 5 10 up and down is 10 kilometer. For that you have to spend nearly half liter of petrol. That's all. This is the work you have to tell me. When I ask something, you first listen what you have to tell. That only you have to tell. Something momentum from one place to another. So you have provided energy to the your bike. That's all. So what is the energy what is the energy? It's a form of energy. Okay, it's not petrol is a source. It's not energy. That the energy only we going to see step by step. Okay. So some energy you have provided to the bike to travel from that place to here, from again to travel to that place. That's all. So you have spent, but nobody has opened the mouth to tell like this boldly, right? I have traveled from house to this place. So I have spent half liter of petrol. Probably it will be half liter. And from here I travel back to the home in the night. So it will be again totally it will be up and down. It will be 5 kilometer plus 5 kilometer. So it will be hardly 10 kilometer. For traveling 10 kilometer, I cannot take a walk. Will anybody take a walk for 10 kilometer? Nobody will take it. So you have to take some energy. You have to take some vehicle which is so we have provided petrol. So I have spent half liter of petrol. I have provided energy to the bike. That's all. What I have spent what I have spent the energy is zero, because you not do anything. Just you can see, that's all. So you not do anything. You have to spend only this half liter of petrol to the energy. So that's why you should have expected from it. When I ask any question, immediately I have to get reply for like this only. Okay? Can I open the door? Can I move the table? This is a question. This is the answer. Okay? Anybody can move. Now also you can move the table. Okay, so you have to think a little bit and you have to tell the answer. Okay, this is what something I have said. So petrol is not something. So petrol is how much? 1 liter petrol is 120 rupees. No, hardly 120. So half liter petrol is 60 rupees. So 50 rupees. You have to spend, including GST or excluding GST? No GST, no? So it's only 50. So hardly 50 rupees. So per day traveling itself, you have to spend 50 rupees. That's all. So like that you have to spend. So 50 rupees is a huge 50 rupees. So for 1 month, 50 into 10 into 30. So 500 to 1500 rupees for petrol itself you have to spend from traveling from here and there. This and all you have to tell yourself. I will not teach you everything. I have to start from KK Nagar. I have to reach here. It will take this much of time and this much of amount I have to spend. Then again I have to go back. I have to spend this much of time and this much of amount. That's all. Is it clear with you now?
Yes, sir.
So only she is coming or everybody is coming from who other than who is coming? You are also coming. Then you are also coming. But you didn't open where you are coming from. Okay, someplace Chulai made. Okay, but nobody is opening their mouth. No, nobody is opening. When I said you have to say something like some information you have to give, then only I will give another information. Okay, so this is what energy. So you need some source of energy. Okay, that energy we are energy. So where is possibility of energy? Now it comes energy. So if it comes energy, I have for a train I have spent the electricity. So it is a electricity. It is a electrical energy. Okay. Then then you know electric vehicle, right? Electric vehicle. It will run by battery. That is a chemical energy. Okay. So electrical energy, chemical energy. Then if you take cycle, no cycle. Cycle, that is a type of energy. Okay. You are spending your own energy. It's a work energy. No, there is no work energy. Kinetic work is equal to no type of energy. We are telling it type of energy, heat energy, chemical energy. Then chemical energy only batteries. See, electrical energy, chemical energy, then heat energy.
Wind energy.
No, wind energy, yeah, wind also energy. No, wind energy, yeah, wind also energy. No, then lot of wind energy, hydrothermal energy. What is a hydroelectric energy?
Water.
Wind, you know, right? Wind. I did explain you about wind energy. It says fan is there, right? Yeah, of course you can see the template there. Fan is there. I am taking this to the mountain. Which what is? Huh?
Navy.
Wind. So I am taking this fan to the top of the mountain. Okay. Now what will happen? Top of the mountain, if I take, the fan will rotate itself. So the fan will rotate itself, and from that I can produce the electricity. Okay. So if I keep instead of that, you can keep it in the land. But land, if the same fan is here, it's not rotating. But when you keep it the same fan, you can keep it a certain height with about something around 1 kilo. I think up the 1 feet. They will keep around 50 feet, something like that. They'll you might have seen, no, wind energy. That fan blade. It will be kept. It will be in not here. Huh? 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 Windmill. Where it is?
Navy.
No, naval is different.
Sir, windmill.
Naval is there? No, this is situated in Madurai. In windmill. Okay, windmill. Okay, where it is now? Windmill is located in Madurai. Madurai.
Sir, Navy.
Now naval is it and windmill is there? More. Okay. Naval that will come now. Now I am going for now I am going to windmill. So that is a windmill. Okay. So that's a windmill by which the high pressure of oxygen will rotate the fan blade. From that you can get. So now this is the second. This one more alternate energy. Okay. So one more production of energy. Now another is hydroelectric energy. What is the dam? When the dam is full, they will open the water. So when they open the water, what will happen? The water will flow with a high speed. So that will rotate the turbine. From there they will produce the electricity. So later say a lot of things is there. Now again I am going to solar energy. That solar panel, I think where is located in Chennai? In Chennai, it's Guindy. They opened it. Okay, so they are located in Guindy where the sunlight will be, where the sunlight will fall on the photoelectric effect, solar cell, and from that will produce the current. So various form of energy that we can produce now. Now another one is thermal energy. Where the thermal energy is located in Chennai, in Ennur. You know Ennur, right? That's why the power is almost some of the power surrounding areas surrounded by Ennur, where you need the coal. Now this coal shortage is there. So that's why you got that power current supplies switch off for quite some time. Coal, what they will do? They will heat the coal and produce the. No, they will from the heat the coal. You will not get the electricity. Water will be converted into water vapor. So vapor comes with the high pressure. So the high pressure is increases, the production of current will be more. When the pressure decreases, production of current will be less. That's all. The pressure is directly proportional to the production of electricity. Okay. So they will produce the current and they will distribute the current. So this is the thermal energy. So nuclear energy. Then we go for nuclear energy. Nuclear energy we already discussed. No, uranium.
Radium. It's a kind of waste.
Huh?
From nuclear waste.
Nuclear energy. What is the source of nuclear energy? Uranium-235. Uranium-235 and bombarded with neutron, you will get the uranium-236, which will give the barium, krypton and energy. So that energy will be utilized to heat the water. So the uranium, so when the water is heated, water vapor will be produced. So that will produce the very high pressure of water. That helps to rotate the turbine. That will produce the electricity. Where is the nuclear plant? Kalpakam. Now Kalpakam, Kudangulam. What is the difference between Kalpakam and Kudangulam? Kalpakam is 100 megawatt, Kudangulam 1000 megawatt. That is the increasing this capacity. So if we increase the capacity, what I will get?
More energy.
More? More electricity. Energy is different. More electricity, more electricity. Okay, more electricity I will be getting it. So what is the basic I need? Here I need is uranium 235. So now what we seen? Thermal plant, nuclear plant, hydroelectric plant, windmill, then solar panel, then battery, chemical energy. Which batteries? What is it they will do? They will charge a battery. You know, right? Electric vehicle. This nowadays every week you will find one electric vehicle catches fire. All the electric vehicles catches fire, and every week one vehicle catches fire. Due to, because what I am switching on, I have to charge it. Then I have to use for my routine work. Okay. Once the charge is over, it will tell that there is no charge. Again I have to charge it. Okay. So when the charge is there, it can the heating effect. That the battery, what we are using, the same lithium batteries. The same lithium batteries only, which is laptop, right? We are using in laptop, that UPS. What is a UPS? It is able to withstand the charge. It is able to withstand the electricity. When the power is not there, it will be released. So okay, when the power is not, it will be released. The electricity will be released. That's the same thing like batteries. You can able to instant for 2 to 3 hours in laptop. Okay. Everywhere all are lithium batteries. What is the function of lithium batteries? It will be able to charge it and it will be released when it is not power is not there. Okay. So this is a chemical energy, heat energy, then thermal energy, hydroelectric power. So now what will come under heat energy? Heat. Electric cooker. Heat energy. Electric. See, now I am going for
Electric energy converts into heat energy.
electric energy.
Converts into heat energy.
Heat energy. What all will come under heat energy? How many thing we have seen now? Heat. So electric energy, nuclear energy, chemical energy, then heat energy. Okay. So what will come under heat? What will come under heat? Thermal energy. That will come under heat. What is thermal energy? What is the thermal energy? Burning of coal. That will convert into vapor. That vapor is with a high pressure. All the same thing. The high pressure increases. The turbine will rotate. So they produce electricity. When the pressure is increases, I have to increase the pressure. What I have to do? I have to increase the pressure of water vapor. What I have to do?
Increase the temperature.
How I can increase the temperature then? Burning more coal. When the more coal is utilized, it will convert the more water into water vapor. When the water vapor increases, what will happen? The pressure is that keep on increasing. When the pressure increases, obviously the turbine rotation will be fast. So when it's connected to the electricity, when it's connected to the motor, it will rotate and so it will produce a more current. So it will produce the more current. That's all. So it will come under various. So it's not about only from chemical energy I can get the power, and from the nuclear energy I can get the power. So various method is there. Then hydroelectric energy. So hydroelectric power, hydroelectric energy. It's type of hydroelectric power. Then solar energy. Solar energy also is there because where there is no heat is involved there. That's different because when sunlight is fall on it. Simple, you have to keep, you know, right, how solar panel will get it. Solar panel will keep, they will keep it in the top of, you can use it in the house also. You can use it in the house also, connected to the, you need not get current from the EB board, electricity board, okay. You can keep it solar panel in the top of the roof and get connected to your main supply. From the main supply, they will distribute your house, entire house will get your electricity. But what is big disadvantage is there? You can get it, everybody can get it, no? Huh? Rainy season, nothing will happen. If you keep it, nothing will happen. Even if it rain also, nothing will happen. Continuously rain it for 10 days also, nothing will happen to it. See, you are keeping solar panel, the company is designing, everybody knows that no, the rain will, they'll keep in the roof of the, so if it is affected,
No, sir. If in case of rain, it will produce electricity. Less amount of electricity.
less amount of electricity it will produce. It will produce electricity, but it will produce reducer because sun rays will be lesser, so it will produce less amount of electricity. But any case it's producing though. Then yeah, that's a keep, they will keep inverter. They are in remote area, they having solar panel, they'll keep like that because in sunny rainy season it will not produce that much of electricity because no sunlight. So they'll keep that batteries etc. Then it will store it in the battery and it will be released. But what is my question?
Disadvantages also.
Disadvantage of solar panel. Everybody can keep. No, why they didn't keep?
High cost, sir.
High cost. So it's very expensive. If this is cost, I think 1 unit, I think 2 rupees or 3 rupees. That will be 10 times, 20 rupees or 30 rupees. So it will be very expensive. So nobody is going for that except a few companies. Except if a commercial like a remote region where there is no electricity supply itself. If you go out of Chennai, go itself, there is over. You don't have that much of electricity power supply. For Chennai, no problem. This is capital. But out of Chennai, if you go, keep on going, you will not get. Everybody belongs to Chennai, right?
Yes.
Chennai. Okay. If you go outside of Chennai, keep on. If you go outside of Chennai, the distance increases means the power supply will decrease. It's not. No, it's not, amount of. No. If you go to out of Chennai, for Chennai they will provide this much of capacity of electricity. Okay. If you go out of Chennai, they will not provide that much of electricity. Only half of only they will provide. They don't have enough electricity to provide them. For Chennai, no problem. Chennai is a capital, so they provide it. So if you go outside of the things, you have provided on that on the special occasion like that place where they need urgent electricity, they go for solar panel. Where there is no option for electricity, they will go for solar panel. So but it's very expensive. But they have to use it because they need some emergency purpose. Only that people will go for solar panel. It's very expensive. That's all. This is what the energy comes there. Okay. Now we go for so in the scenario now we will go for so if you go for E equal to mc square, how the energy produced in the sun, you are getting sunlight. Okay, sunlight you are getting it, that's from the sun. So what is the age of sun and what is the age of earth? Sun, age of sun and age of earth.
5.5 billion years, sir.
Yeah, 5.5 billion years. So 5.5 billion years to the earth is also formed around that area only. Around no, it's not a 5.5, it's a 4.5.
5.5
It's nearly around that region, around 5 billion years. Okay, 5 billion means 5 billion, another it restored for another 5 billion. Okay, 5 plus 5. Okay, so in that case, what will be the so how the energy of the earth is continuously getting the energy from the sun. If there is no energy from the sun, what will happen to the earth?
Life does not exist.
So life will not be exist. Life the evolution process will be stopped. So evolution process stopped. What is the age of human? Age of human. Human are right in biology, no? Age of human, age of mammalians, that is apes. How is the human evolved from? What is the age difference? What is how human evolved from? Monkey. Which type of monkey?
Ape.
Apes. Which specific?
Sapiens.
Homo sapiens. Okay, before that who arrived?
Monkey.
Monkeys. what is the original origin of monkeys? No, original origin of monkey. Huh? Original origin of monkeys. So human came from monkeys. No, monkeys. That's what I'm asking. I'm asking you, just telling you are asking me. Okay? Human came from monkey. Which type of monkeys? Homo sapiens is human. Humans are Homo sapiens. Which type of monkey? Which type of monkey? From which type of monkey? Chimpanzee. Okay. Okay. Chimpanzee. So chimpanzee arrived from which human? Which species? Monkey. Before monkey, what arrived? So what? This itself. No, that's different. That's different. That's dinosaurs, and this one is different. See, human arrived from monkeys. No, which chimpanzees? Chimpanzee arrived from? Huh?
That's the evolution, sir.
That's only I'm asking. Which species they evolved?
That's not predictable, sir.
Huh?
No, predictable.
Everything they predicted. Huh? No, I didn't understand. What? Huh? What is it? What is it? No, you just tell it to me. No, that is belong to chimpanzee. That is belong to chimpanzee. That's why I told you. Human two type of monkey. So in that one monkey you can take, chimpanzee. That chimpanzee from that arrived from the another animal. That only I am taking. Which animal I am asking? Huh? No, you can take various form of monkeys you can take. That is one way we are taking it. Okay. So this okay. How many? No, you didn't answer. No. See, when I ask question immediately you have to answer. See, I forgot. I going to another part now. Okay. What a question is humans evolution. Then monkeys. Monkey. Then before that, it's a type of.
Amphibians.
Type of mouse.
Amphibians. Before that amphibians arrives. Between this amphibian and this one only monkeys, this species arrived. That is what do you tell in nari? What do you tell in nari in English? Fox. Fox. It's a type of fox. From there only that chimpanzee. From this only all monkeys arrived. Like chimpanzee, gorilla, all these arrived from this type of fox. I don't know exactly what is the type of fox. From that fox arrived from the amphibians. That is, it's a type of fox. It's a type of fox. Okay. Then that arrived from the amphibian. Amphibian, you know, right? What is a perfect amphibian? It can live both in water and land. That is the amphibian is the one that came from the sea. It came from the sea. From that specific type of fox arrived. From that only the monkeys came to arrive. Because it has a tail, I think. Fox will have a tail, no? Fox will have a tail, etc. This also will have a tail and etc. From that only the humans arrived. So all these are species. How long it took? It took how many? What is the total evolution of this species? Not 5. It took total earth of sun both are 5 billion years. Okay. This one, the evolution have started recently only, around 0.5 billion. 0.5 billion means how many years? 5 billion means how many years? 5 billion into 100, 500 crore years. So the age of sun and the age of earth is almost 500 crore years. age of sun and earth, okay, from where the earth is evolved from the sun. When the earth is evolved, not only the earth evolved, all the planets evolved, all the Mercury, Venus, earth, Mars. What is Mars belt? Mars belt, where the asteroids are located. Mars, between Mars and Jupiter, there is a Mars belt is there. In that only all the asteroids are located, which is millions of years, millions of, not one or two planets, it's not one or two asteroids. Millions of asteroids are located, that's called Mars belt. So that is located there. So everything is arrived from the sun. So this life is totally almost 5 billion years. So in that life is evolved around 0.5 billion years. 0.5 billion means how much? 0.5 into 100. 0.5 into 100, 50 crore years. So it took almost the earth having the organism evolution around 50 crore years. So the earth is providing energy. So for past 50 crore year plus beyond that, so 450 plus 50, 450 plus 50, 500. So past 500 years, the earth is providing, the sun is providing energy to the earth. It will provide for another another 5 billion years. So 5 plus 5 plus 5, 10. So 10 billion years. 10 billion into 100, 1000 crore year. So that is our total life of the earth. So total life of the sun. So sun is radiating energy. So what type of energy is going on? It's a process of nuclear fusion energy. Nuclear fusion energy, which is hydrogen energy. Two hydrogen and hydrogen will combine to form a deuterium. Deuterium and hydrogen will combine to form a tritanium. So this energy is evolving past 5 billion years, and another 5 billion years it will evolve. So this is the Einstein equation, E is equal to mc square. That is how the mass of the energy decreases. That will produce the energy. The decrease in mass will lead to the increase in energy. That is E equal to mc square. So this is what Einstein got the Nobel Prize. Okay, you know, right, Einstein?
Yes, sir.
So this is what Einstein got Nobel Prize, the decrease in energy. So sun will radiate energy for another 5 billion years. So sun is radiating energy for past 5 billion years. So 5 plus 5, 10 billion. So the E is equal to delta m c square. So if we extend it, you need not utilize sun. You can go to you go to thermal plant where current is produced. What is the I want to increase that pressure. Okay, what I will increase now?
Heat.
I want to increase the pressure of water vapor. What I will increase now? In thermal. Uranium is a nuclear power plant. I want to increase the
temperature.
mass. You can increase the mass. You have to increase the mass. That will increase the temperature. So that will increase the water pressure. Water will be converted. So if more water is converted, the pressure will be increased. If the more pressure is increased, the velocity of the turbine will increase. The rotational motion of the turbine will increase. When it's more rotational motion increase, what will happen? That will connect at high amount of electricity will be produced. So now this is also here also you can tell the equation example. Delta E is equal to delta m c square. So the more the coal produce production of the more coal if you increase, if you increase the mass of the coal, what will happen? If you add more amount of coal, that will produce the more energy. What energy it produced?
Thermal energy.
No, type is thermal energy, but what will finally it produced? Electric energy or electricity. So that means electricity is produced. Electricity is produced from the from the coal. That's all. So this is somewhat another example. So that example you can take. This example you can take. All the example you can take. So work done is equal to force into distance. So distance is x. We keep it constant as x. F is equal to force. No, I didn't ask any question. No, in nuclear power plant, thermal power plant, wind energy, windmill. Okay. No, some question is there. I forgot which question to ask. So work done is equal to force into distance. Okay. No, I forgot. I had to ask some question. I forgot. I will come there. To that I will come now. Okay. So I will come to that part later. First work done is equal to force into distance. Work done is we denote it as a W. Okay. F is a force. So x is the distance. So W is equal to F into x. So the work done by the variable force, that is the force that is a variable force, that is force is equal delta W is equal to F into delta x, that is the distance. I am taking as this is the x. Okay, force acting on it F, work done is equal to force into distance. Now I am taking is I am dividing into 4 part. Okay, 4 part. So when I divided a 4 part, what I am doing is x1, x2, x3, x4. So now what I am doing is what I did first one W work done is equal to force into distance. So if any force acting on it, this distance I am taking as x. Okay, this distance I am taking. So F is work done is equal to force into distance. Now I am taking is 1/4 of it. 1/4 means how many part I will divide? 4 part. So I am dividing this one into 4 part. So if I divide this 4 part, what I will do? This one is x1, this one is x2, this one is x3, this one is x4. So what now I am doing what I am doing it now. Same I need work done. Work done is equal to work done is equal to force into distance. So what is the distance here? x1. So work done is equal to force into the distance. So what I am doing is I am calculating into this one into 4 this I teach you, I think.
Yes, sir, you are already
No, for this fellow.
No,
Did I teach you?
No, sir.
Okay. So this one is a first one as convenient. First one is convenient. Force into work done is equal to force into distance. Now second one is that second one what is that I am divided into 4 part. 4 part, only one part I am not going into I am not going to second, third, fourth. I am not going. Just one part is sufficient. So for calculating to one part, what I have to do? W is equal to force into
x1.
I am dividing the x1. So x1 is equal to now F into x1. So F into x1 I am getting, if I do the work done I am getting for the only one part. Now I need for the total part. What I will do now?
Into 4.
Into 4, or I have to calculate for another part. Go for another part. Another part work done is equal to force into x2. Then here this part is x3. F into x3. This one is the x4. So if I add all these things, I will get the total work done. Total work done. So here W is equal to F into x1 plus. No, wait. Any one person will tell. If you tell everybody tell means what I cannot understand. Any one person you tell. Any one person tell.
Total work done is equal to F into x1 plus F into x2 plus F into x3 plus F into x4.
X4. Okay. Now I am going for another option. Okay. Another option what I can go? Total work done. No, any one person. No, any one person you tell. Any one person you tell. Any one person. Who will tell? Who will tell?
Finding any part, one part and multiplying by
No, wait. You already told, no? For one part. If I want to miss, I have to give another one. Who will tell? Work done. Now, first part, what did she told? Work done is equal to f into x1, f into x2, plus f into x3, f into x4. Another part? Another method? Who will tell? Just tell, quickly tell. Who will tell? Who will tell and tell me? Who will tell? Did you understood or not my question? I understood my question. I give the first answer also. Second method. That only I am asking. Okay. Okay.
What is equal to 4 into f by
4 into
f by x. F into x.
f into x. 4 into f into x1. That is what I am telling you. Yeah, I am calculating. This is one. See, if I am taking for x divided into 4 part, I am taking f into x1. X1 I am taking f into x1. So I have got first part into 4. So f into x1 or f into x2 into 4 or not or equal to or equal to f into x3 into 4. Then equal to f into x4. That's all. Anything, either you have to add it or into 4. That's all. This is what I ask. Is there anything new I am asking it? What I am asking you from what I teach to you. That's all. When we started? 12:20.
1 hour.
Almost 1 hour. Still lot of things there. Okay. Yeah, almost complete. Still time takes. Okay. Kinetic energy. Now total energy. Total energy can be divided. Total energy is equal to potential energy and kinetic energy. Now we go for first kinetic energy. So kinetic energy is equal to kinetic energy is F is force is equal to mass into F mass into acceleration. F is equal to ma. So half mv square. Potential energy is equal to kinetic energy is equal to half mv square. Potential energy is equal to potential energy is equal to mgh, mass into acceleration into height. mgh. Potential energy, kinetic energy is equal to half mv square. Okay, potential energy is equal to half. No, not half. mgh. What is g? What is g? Gravity. You didn't read anything in the gravity. Mass is m is mass, g is gravity, h is height. This. Okay, then you will tell related question. Okay, if ask related question, you will tell. Okay, there is no better not to ask anything. Okay. Okay, I am going to LIC. I am going to the LIC building, which is Anna Salai, which I have in 10th floor. Okay, I am throwing a stone. That's all. Throwing a stone. Okay, I am throwing a stone. What it will do? It will try to fall. It will try to fall. Okay, it will fall. Okay, it will try to fall to the ground surface. Okay, so what is the speed? It will be. That speed is called the no. The kinetic energy. So the kinetic energy. What is the kinetic energy? That it is. What is the kinetic energy? That it is possessed. Yeah, that this thing itself we can take. I am taking one football and I am taking one tennis ball, which will fall for the football. Because this also half mv square. Here also half mv square. So both, but which having higher mass? Football. Yeah. So which having higher mass? Now we can take it as a m1. and which has a lower mass you take it as a M2. So now I am taking that M1 is greater than M2, KE of M1 is greater than KE of M2. That means it has the most kinetic energy. Okay, kinetic energy is higher. Kinetic energy is higher. So if kinetic energy is higher, where it comes from? Kinetic energy. Kinetic energy. Kinetic energy is okay. Okay. Kinetic energy is okay. Okay. But where? How you got the kinetic energy now? Kinetic energy is equal to half mv square. So here also kinetic energy is half mv square. But football I am marking as marking as M1. Here I am football tennis ball as a M2. So what I have to write here? M1 is greater than M2 because football will have a higher mass. Everybody knows that football will have a higher mass compared to tennis ball. But where the kinetic energy, see, when I moment it kept the ball, when I moment it kept the ball and leaving my hand, what it will do immediately the moment it starts the traveling process. Here also I am keeping the ball, tennis ball, I am going to the top of the floor, etc. I am keeping my ball, I am removing my hand. What will happen the moment I remove the hand? It will try to travel. It will try to travel. Everybody knows that it will try to travel everything. Now what is the question? What is the kinetic? It is travelled. So that is called the kinetic energy of mv square of mv square. Where the kinetic energy comes from? The kinetic energies come from the potential energy that it has stored. That means it has stored lot of potential energy. I am lifting. I am traveled. I have taken the ball. Okay, I have taken the ball and I have traveled 10 steps. I have traveled it. Okay, 10 steps I have traveled to the 10 floors. I have traveled to the LSC building, top of the LSC building. So the potential energy is stored. So that potential energy high. What is the height here? From the 10th floor height will be, normally it will be 10 feet. Okay, 10 feet difference. So 10 floor means how many floor? It will be roughly 100 feet. So 100 height is 100 feet. G is gravity. What is the value of gravity?
9 into 10 power 8 ms power minus
9.8 meter per second square. Gravity 9.8 meter square. What is the value of gravity? What is value of gravity? 9.8 meter per second square. 9.8 meter per second square. So mass of the thing you can substitute the weight. Approximately what is the weight? It will be football. What is the football and tennis ball? Tennis ball means it will be not even or what will be probably I think 100 grams or something it will be 100 grams or 100 grams it will be. If you go for football it will be approximately 1 kg. So 1 kg, this one will be 0.0 kg. 1 kg versus 0.0 kg into 9.8 into 10 feet height from which it's done. So it will be approximately 10 feet. Okay, 10 feet, something around 10 feet into 10 feet. That's all. So this we make. So I got the potential energy. So potential energy I got, from that I got I have to substitute for the kinetic energy. So potential energy got from the speed from this. So I got the potential energy. This potential energy is converted into kinetic energy. That means when the speed of the things increases, what will happen to the potential energy?
also will increase. Decrease. Potential energy decreases.
When the speed of the kinetic energy increases, what will happen to the potential energy? Huh?
Increases.
See, now you got it. Now you got it. Now you got it. So what happened when the speed of the kinetic energy increases? Okay, what happened to the potential energy? Huh? Anybody? Any one people to tell? Rest. What will happen to the potential energy when the kinetic energy increases? At rest, it has a full potential energy. Okay, I am taking to the ball. Okay, this is at rest. Potential energy full.
Increases, sir.
Potential energy full. Kinetic energy is 0 because I kept it at rest. Okay, I am leaving it. Now the kinetic energy keep on increasing. For M1, kinetic energy of M1 is greater than kinetic energy of M2. KE1 is greater than KE2 because M1 is greater than M2. So what will happen to the potential energy now?
Decreases.
Huh?
Decreases. Decreases, sir.
Okay, any one person you tell. Huh?
Decreases.
Who is telling?
Decreases.
No. So what are you telling?
Decreases.
Yeah, potential energy will decrease. The potential energy will decrease. The potential energy decreases means the kinetic energy will increase. So this is so total energy is the total energy. So total energy is equal to potential energy plus kinetic energy. So the potential energy keep on decreases, kinetic energy keep on decreases. Okay. Now comes the two possibility. Kinetic energy 1 is greater than kinetic energy 2. Okay. So which will have the potential? Which will have the least potential energy and which will have the maximum potential energy?
Least potential energy, kinetic energy.
Kinetic energy of 1. What is 1?
High kinetic energy.
What is 1? KE1 is greater than KE2. What is KE? M1 is greater than M2. KE1 is greater than KE2. What is M1?
Football.
Football. Yeah, M1 is a football. Kinetic energy is?
Higher.
Kinetic energy will be higher for football. This comment. So what happened to the potential energy now?
Potential energy is least.
For M2?
Potential energy is higher. Correct, sir.
So if high kinetic energy will lead to
Low potential energy.
high kinetic energy. So it has utilized the full kinetic energy. Okay, potential energy present will be the less. High kinetic energy will have a least potential energy. Less kinetic energy will have the more potential energy. Okay, that's all. This is the concept. So we have derived first M1 is greater than M2. Then KE1 is greater than KE2. Now
P1 is less than P2.
P2 is P2 greater than P1. P2 is greater than P1. Yeah. So now you understood this concept.
Yes, sir. Yes, sir.
Okay, you have to repeat. Somebody repeat it. Okay. Who will repeat it? Everything you have to repeat it. Who will repeat it? Boldly you have to repeat it. Who will repeat it? Quickly you have to repeat. Okay? You have understood the concept. You have understood M1 is greater than M2, which is football versus greater than tennis ball. Okay? Then KE1 is greater than KE2 because kinetic energy of football will be greater than kinetic energy of football. Now what is the third one?
Potential energy
P2 is greater than P1 because this will have less potential energy and that will have the less potential energy will have more kinetic energy. Here potential energy, so it has less. Tennis ball has the less kinetic energy. That means it will have a more potential energy. Okay. So who will repeat it? What I told you, you have to repeat it. That's all. You have to stand up and repeat it. That's all. Who will repeat it? Who will repeat it? Just repeat. Yeah, what I told you, you have to repeat it. You have to just stand up and repeat it. That's all. Who will repeat it? Who will repeat it? No. No. No, who will repeat it? Who will repeat it? You want to repeat? No, oh, no. Yeah. Just you have to repeat. Just you, do you understand or not? Okay, just you have to repeat it. That's all. Huh? No, what happened to you? You don't want. Okay, but next time I will ask you. Okay. No, just.
Mass one is the tennis ball, sir. M2 is greater than M1, sir.
Mass one is the. No, no. What is mass 1?
Football.
So mass 1 is a football. So which one will be the greater? M1 is the M1 is greater than M2. Okay. Okay, you tell. Okay, you tell. Yeah, just you can. No, you can sit down. Sit down separate.
M1 வந்து football, M2 வந்து tennis ball. So P2 is greater than P1. So okay, M1 is greater.
M1 is greater than M2. M1 is greater than M2.
Then kinetic energy 1 is greater than kinetic energy
2.
Then potential energy 2 is greater than potential energy 1.
No, first kinetic energy is equal to K is equal to half mv square. Half m1 v1 square is, so kinetic energy 1 is greater than kinetic energy 2. So half m1 v square is greater than half m2 v square. Okay? Like that you have to elaborate, everything you have to elaborate. First kinetic energy is greater than kinetic energy 1 is greater than kinetic energy 2. Half m1 v square, half m1 v square is greater than half m2 v square. Okay, like that you have to expand it. Okay, now comes the finally potential energy of m1, potential energy of m2 is greater than potential energy of m1. That's all. This is what I asked. That's all. It's hardly 5 points. No, 5 points or 6 points. That's all. Now potential energy of the spring. So I have taken the scale, I attach the spring to it, and I am stretching the spring. What will happen? It will try to extend. So that extension is x. Okay, x is not from the scale. Take a scale, hang the spring to it, add some mass m. Okay, and then you are extending the mass to a certain distance. That certain distance is called as x. Not the distance is not from the center of the scale, not from the total length of the spring. Okay, from the total length of the spring you are not taking as x. Okay, you are taking I am taking the spring. Okay, I am taking the spring attached to the scale. Okay, now I am extending the spring. If I leave the spring, what will happen? It comes to the rest. What is x then?
0.
No, when I what is x? Huh? Distance. From where to where? That's why I am taking. It's not from the scale. It's from the mass. From the mass to the end of the mass. From the where the mass is at rest. From the mass is at the rest, I am extending it. Okay. Then I am leaving it. What will happen? The spring will now come to the rest. Okay. How what is the distance it is extended? Distance of extension. Spring. X, that is the x. So what is the force is directly proportional to the distance here. Force that I am applying to the certain distance. So I am taking I am applying the force to the mass. I am extending it. Okay, to some extent, which is x. So I am leaving it x. What is the distance now?
X.
0. When I extend it, it is x. When I leave it, it is 0 because it came to the rest. So the force is directly proportional to x. Force is equal to k into x. X is the force constant. So work done is equal to integration of 0 to xm x. So which is xm, which is nothing but the certain distance. So into kx dx. So it will be now integration of x, integration of k is constant, you have to take outside. So integration of x dx is equal to integration of x dx what? X square by 2. Integration of x dx which is x square by 2. So into x square by 2 divided into already force constant is outside. So k. So k x square by 2. When we started? 12? 20. Now it's almost 120. 1 hour over. No? Almost 1 hour. No? Okay. Now principle of collision. The principle of collision says that principle of collision. What is collision? You know, right? You might have observed. You might have observed that in the road itself you can observe it. Okay? If two car, you have to take specifically car. Okay? Car is colliding with the two cars. When the two cars will collide? Car is colliding with accident. When the two car will collide, when they coming in the opposite direction, when they come in the opposite direction, that is collision. So that is the head-on collision. Head-on collision. So the head-on collision, if two cars collide, okay. If one lorry and one car collides, what will happen to the car? What will happen to the car? Huh? First we go for car. Car and car colliding. What will happen to the car? Both will be damaged. But now car and lorry collide means what will happen? No, any one person you tell. Car will be damaged. So that car is because it cannot withstand before that lorry big garage. That's a lorry. So it cannot withstand. So it has to hit it and come back. It will become like almost what it is? Almost like a duster you can keep. It become like a dust. Okay, that's all. It's of no use. But what happened to the lorry? Nothing will happen to the lorry because it can withstand. So that is the if two car collide means that is elastic collision. That is the kinetic energy is not lost. In what direction it collided, it will come in the opposite direction. So that is elastic collision. Elastic collision means the kinetic energy of the both the things, that is nothing happens, not that much damage to the both the things. So not that much damage happened to the both the things because both the car collided, both will come in the same velocity, both will have the same mass. So if the two masses and two velocity coming in the opposite direction and colliding it will not be affected. That's the elastic collision. Now lorry and car coming in the heading in the opposite direction, by which the velocity of the velocity of the car now becomes zero because it will not come back because it has become like a, what do you tell? It has become like a, what you will tell? Flat sheet, something like flat sheet, because so it become flat sheet and it has lost all this thing. So the kinetic energy is lost. Nothing is there. For it no problem. For lorry no problem. So the kinetic energy lost itself. So it is an inelastic collision. So this is becoming elastic and inelastic. That is now the car, once the car become flat, it has lost all its kinetic energy. But here it is it also lost both of them have lost the kinetic energy. Do you understand now? I am going to car, both having same mass. They are having same mass, same velocity. Okay, both of them have lost the kinetic energy. But once it is collided, it will come back. Okay, collided, come back. Both of them have lost the kinetic energy. In experiment number 1, where two cars of same mass, same velocity colliding. Once the collision, the speed will be decreased. For what? For both the cars. But I am coming here. Now lorry and cars are both again. When accident happens, the velocity, the mass is different because lorry mass is different from car mass. Velocity also different. Velocity of the things is different from velocity of the car. So after collision, what will happen? The car. What is the velocity of the car after collision? But here, what is the collision? What is the velocity of the car? Both the car after collision? It's not zero. It's not zero. Decreases. Velocity decreases. Velocity decreases is different from velocity is zero. Here, collision. Two cars are coming, and collision is taking place. After that, it's moving away. Now, what happened to the velocity? Decreases. So that means. Let us assume the decrease after collision VF. VF is final velocity. When they are coming before collision, it is initial velocity, which is VI. So now VI is
greater than VF.
VI is greater than VF here. Okay. Here now I am going here. Okay. Now I am taking lorry. It's moving with the lorry. Lorry is both lorry and car is coming. Mass is greater. This one is mass is lesser. So you forget about Lorry mass. Okay, just take this mass of take that mass of the thing itself. You take mass of the car. Okay, now it's colliding with the certain mass is coming with velocity is vi. Okay, now after colliding with lorry, what happened to the velocity of the velocity of the car?
VI. Sir, V is not velocity. Lorry velocity.
No, lorry velocity, lorry mass you forgot. We don't need it. Just you take this velocity of the car. Okay. Now initially before collision, vi. Now vi before collision is called as a vi, which is initial velocity. After collision, it becomes the vf. So vf will become 0 because after collision, what it become? It becomes like a flat surface. So no velocity, nothing. So vf is 0. Now you are coming here. Experiment number 1. So both the cars are colliding and coming back. So which is vi and vf? Initial velocity. That's collision. Before collision, vf is the final velocity after collision. So now what I can write here?
VI is greater than VF.
Any one person. If you tell Goras, I cannot understand. Any one person tell. No. Any one person. I told you any one person. Any one person. Who will tell? Who will tell? Any one person. Okay, you tell. Huh?
Vi is greater than VF.
No. That's what I am telling it. No. How Vi will be greater? When the collision taking place, that is Vi. Before the collision is Vi. When it's after collision is Vf. Now which will have a greater velocity? No. Vi. Vi greater than Vf. That is the final velocity after collision will be decreased. The collision final velocity after the thing is decreased. So which will have a higher velocity now? Vi will be greater than Vf. That's all. Now I am coming to back here. What is the initial velocity here? Vi. After collision it is what is the velocity? Vf. Now what I can write? Vf is equal to 0. So now another equation what I can write?
VI is greater than VF.
Another equation what I can write? Any one person tell. Not everybody Goras. I can write as Vi is greater than 0. Vi is greater than 0. Why? Because after collision, whatever the velocity is 0. So Vi is greater than 0. That's all. This is the inelastic collision. That's all. Over. Okay.